Now we're going to look at another example of using the inverse normal distribution, but this one's a little bit more complicated because we're going to be looking at the area in between two unknown values. So this type of example has its own set of steps because it is just a little bit more complex. So the first two steps are the same. We're going to draw our curve and shade the approximate area that we've been given. But then we're going to find the area to the right of the smaller unknown z-score, which we're going to call ZA. Then we're going to use Excel to find that ZA value. And then our other unknown z-score, ZB, is going to be the same value but positive. And we always know that it's going to be the same value but positive because of symmetry. And then we're going to use the z-score that we find and our x value equation to find both unknown x values. So wanted to write in here symmetry. This is because of symmetry. So let's look at our example. This is the same example we've been working with for the previous few problems. The weights of newborn giraffes are normally distributed with a mean weight of 125 pounds and a standard deviation of 15 pounds. 90% of newborn giraffes weigh between what two weights? We're just going to ignore my typo in that sentence. Pretend it's not there. So the first thing we need to do is draw our curve, which in these notes, I've already got it in there, but if we don't have it pre-drawn for us, this is where we need to draw that. And then the second thing we do is we shade the given area. So we've been given 90%, so that's how much we're going to shade. We're going to end up shading 90% of our curve. And then it's between what two weights? So I'm going to shade the middle 90%. Whenever it's between, we're going to start in the middle. So I'm going to come to the middle of my curve this time, and I'm going to shade outward so that I've shaded approximately 90% of my graph, and I want it to be even on both sides. And then right here is where my ZA is. This is on the lower side. And then up here is where I put my ZB for the higher one. So this middle section is 90% of the graph. So I've shaded 90% of my graph. That means I have 10% of my graph unshaded. And this 10% that's unshaded is split between the area below ZA and the area above ZB. And because of symmetry, because the normal distribution is symmetric, I know that I have the same amount in both regions. So half of 10% is 5%. So that's how much there is in each region. And this is how no matter what my middle percent is, I can figure out what's in each of those unshaded regions. And remember, the entire area underneath my curve has to be 100%. So I have 5% below ZA, 90% between ZA and ZB, and then 5% above ZB. And we need to know this because in order to find ZA, this z-score, we need the area to the left. Because when we go into Excel, Excel needs the area to the left of your unknown z-score. And that's what we're going to do next in step 3. So for step 3, I'm going to find ZA and ZB. ZA, I'm going to find by doing norm.s.inv, and the area to the left is 5%. Remember, we can't plug in percentages, so I plug that in as a decimal. And then we're going to look at what we get from Excel. So let me flip up to Excel. Here we go. Equals norm.s. Oh, forgot the S. .s.inv for inverse distribution, 0.05, and enter. Negative 1.64485. I'm not going to use all those decimals though. Negative 1.645. And then ZB is positive 1.645. Again, because of symmetry, there's 5% below ZA and there's 5% above ZB. So the z-score for ZB is the same number but positive. And you can go in and you can check this. You could look at what is the full area below ZB and plug that into norm.s.inverse and verify that you do in fact get 1.645. But now for step 4, we're going to solve for our x values, which, because there's 2 of them, I'm going to call them XA and XB. For XA, we're going to use ZA, and for XB, we're going to use ZB. So XA is negative 1.645 times our standard deviation was 15. I forgot to write it down this time. Plus 125. Since this z-score is negative, we know that the answer should be less than 125. It should not be negative, however, because this represents the weight of the giraffe. So 100.325 pounds. So it's under 125, but it's not negative. You can't have a negative weight. That would not make sense. And then XB, we use the positive 1.645. And then because this z-score is positive, it should be bigger than 125. And that one is 149.675 pounds. So the symmetry piece, the positive and negative, that comes in at the z-scores, and then we use those z-scores and we do the calculation twice for XA and XB. And that is how you find 2 x values when you have the middle 90% shaded.